Welcome to Tech Captains, the podcast that dives into the world of technology. I am Ron Dannenberg, and today with Gareth Thomas, we're thrilled to have Jonathan Kopnick, Chief Technology Officer at Revenue Roll. With over a decade of experience, Jonathan has been a driving force in tech innovation and strategy. At Revenue Roll is leading efforts to adapt to major changes. The one that is being featured seems to be the Apple's privacy updates, but you'll tell us more in a minute. His previous roles include CTO positions at companies like Morph Mallow LLC and F Creative Group, where he transformed ideas into cutting-edge products. So today, Jonathan, we're here to hear about your career, your tech passions, and your vision of the future of the industry. Welcome.
Awesome. I'm glad to be here. Thanks for having me.
Thank you, Jonathan. I mean, just to start, can you tell us more about Revenue Roll?
At Revenue Roll, we identify anonymous traffic. So our clients are primarily e-commerce stores built on Shopify and using Klaviyo or SendLane for their ESP. And we help them to identify the anonymous traffic that visits their sites. So this is people that cart and abandon cart or visit other parts of their site. And we give them their emails, phone numbers, home address, and more than 30,000 different consumer attributes like age, income, gender, etc. And that's built on top of a identity graph of all U.S. consumers where we have more than 3 billion data points about everybody in the U.S.
Oh, wow. And what kind of technology do you use to build that?
So we have a pretty complex tech stack, but the crux of our graph is built on Neo4j.
Okay.
So we got into the Neo4j startup program about 2.5 years ago. And since then, we built a bunch of custom AI models on top of Neo4j in order to be able to do all different types of community detection in order to be able to link profiles together. So if you can imagine, we have like Kafka streaming all different types of data from our client sites. So this is like, their cookies, their fingerprints, their IPs, like all different types of identifying information. And then we're taking that information and linking it together into these like unified household profiles. And those unified household profiles that we're creating, we're able to essentially figure out when somebody goes cross-device or cross-household. So this is when somebody clicks on, one thing on one phone or on one laptop, and then they go, maybe to work or to some other connected household or some other connected workplace. And we're able to stitch those together through these AI algorithms we've developed in order to be able to form like a cross-device, cross-household journey on top of that.
So let's say today I went on your website, I clicked around a bit, I closed the tab. Can you tell that somebody at Coleno came on your website and target me by email?
Yeah, that is the crux of what we do. In terms of the information just described, that our focus is on consumer data, not as much on like B2B data. So we would know like your name, your email, your job title, your phone number, your home address, and then any derivative, phone numbers and emails and home addresses, and then all this other consumer information about you that we get from credit bureaus and ad networks and DSPs and people like that.
Yeah.
So, your purchase affinity, your age, gender, income, properties that you own, things like that.
And you mentioned fingerprinting. So just to be clear, you're talking about browser fingerprinting, are you?
We do a variety of different types of fingerprinting. So yes, we do browser fingerprinting, but we also do like device and network fingerprinting as well, in order to be able to, for instance, look at people that are in like like proxy networks or people that are in like public IPs or things like that.
And so in terms of your tech stack, so you explained that you got into the Neo4j starter program that they have. But how does it help you to use a graph database compared to a relational one that's more traditional?
Yeah, so I actually would say that it's probably one of our biggest competitive advantages, but also it's kind of a different way of thinking. So like traditional, we have a lot of competitors, let's say that they have like a quote unquote like identity graph, but most of them are really built on like relational databases, like traditional data warehouses like Snowflake or like they're using like Redshift or something like that. But the data that we have is really, if you think about it, like social data is networks, right? Like the reason why, for instance, like Facebook built EdgeRank, right? Like why Google built PageRank, why both of those are built on graph databases instead of on traditional relational databases is because there's kind of this Kevin Bacon effect where everybody is connected to somebody if you spend enough time to figure out the things that connect them together. And so, for instance, like if I go to a McDonald's, you go to the same McDonald's, our IPs are connected, right? Like if you add the cart on one site and then you go to another site and you look at that, with, a different email and that email went to that McDonald's, now we have 3 degrees of separation and now we're connected together. And so there's a lot of information gain that happens by making it where those connections to the network are happening automatically instead of you having to do like a manual join between disparate tables and running these processes like in batches all the time. Mm-hmm. And also because Neo4j is like a transactional database that it gives you the capability to do real-time processing on the data that really is not available in most relational databases. So as we have data streaming in from Kafka into the graph, we essentially are able to update these community edges in the graph like in real time, which means that if I click on one page and I go to another page and I give my actual email, that on the third page, we now have email locked and loaded, even if you were to do some cross-device or cross-household journey. And so, as a result of it being a graph, like you really are able to realize those benefits in real time. And one of the other cool things about Neo4j is that it is able to do all that stuff in these kind of transactional workloads. So you have just a queue, and as long as the box is big enough, you just keep processing that queue as it comes in.
And what would you say, like, because you started the company from zero, it's a big data company, like ultimately, like that's what you have, that's the core of your product, handling like petabytes of data. What are the biggest challenges that you found building that architecture from nothing?
Well, first off, it's definitely not petabytes of data, it's probably terabytes of data.
Okay.
But in
Not
terms
yet,
of the...
not yet, you
yeah, not yet, we're getting there. But yeah. Yeah, we're not quite that big when it comes to the data. But in terms of the challenges that I would say that the biggest challenge across the board all the time is essentially remediating cost and balancing cost versus performance. And like specifically, with like running this AI algorithm on a schedule, like streaming in the data from all the clients, collecting it, tagging it, automating those processes, that there are ways where we could just spend infinite money and then we could do all those things immediately and instantly. But many times doing that is not the actual solution to the problems that we have. And so, for instance, like we spend a lot of time making our graph able to do like incremental generation of like new communities versus it doing like these historical, one-off things on the entire data set, right? And like that work in order to do that incremental community generation was worth 10 times, what it would have been if we just like scaled out the server and made it bigger. And similarly, there's all types of processes where it's like identifying the data that's relevant to somebody at that moment, right? And so, for instance, like there might be 50,000 columns in, our database if you were to flatten it, but a user might only need the email back and nothing else, right? And so figuring out the times and places where you can essentially like only look for things on demand that are absolutely necessary, and scaling resources up and down based off of that, like dynamically, like those are the types of things that really have the biggest benefit. And when you're operating at this scale, even though we're not at petabytes and we're at terabytes, that it has a humongous difference when it comes to the cost of doing these things. And so a big part of the reason we've been able to beat the pricing of our competitors is because we've been really, really aggressive at trying to find those opportunities for savings and locking them in once we're
Yeah. And do you use any sort of cloud, I suppose?
Yeah, we're split between Google and AWS, depending on the service.
Okay. And I suppose also that because the nature of the thing you're building, you need a lot of specialists for different areas that you don't necessarily have the skills or knowledge for. But obviously you're still a young company, and how do you handle that? Do you have an army of contractors and freelancers to help you like on specific projects? Or
Yeah,
you just find
that is very adept analysis. We absolutely do. So we only have something like 7 or 8 full-time employees split between like the team in the US and then remote contractors that are now like full-time operating as full-time employees. But supporting them is we have, like a data scientist that's like extremely experienced when it comes to generating, like custom AI models on top of Neo4j. We have, a tracking engineer that is like an expert when it comes to doing different types of methods when it comes to server-side tracking. And we have integrated and had many different people help us with the architecture and setup of the cloud infrastructure and DevOps and things like that. And also like a lot of our team members that are now full time are people where we started with them on a contract basis or with some type of like a test project, and they morphed into full time employees or full time contractors as we really put in the time to kind of understand like what would be the value if they were to come on board full time.
What's harder to find then, like good data engineers or data scientists?
It's hard, man.
I guess they both hard then.
Yeah,
they're both hard.
I mean, I would say that in my experience that the challenge is really finding them at the price point that we can afford as a startup at our stage is really the biggest challenge, right? Is that if I had infinite money, I don't think it would actually be that hard at all for what we're doing. But at the price point that we're at, I mean, we went through probably 200 interviews and maybe 20 actual candidates that initially started working for us to find the 2 senior data engineers that power most of the project right now. And in terms of the data scientists, like we similarly went through a process of going through tons and tons of different contractors before we found the guy that's currently heading up that part of our company. And I mean, I also think that one of the challenges for us that is a little bit unique is that there is also a huge aspect of what we're doing where there's a trade-off between domain expertise of understanding like ad tech, understanding like the unique aspects of like our data and the business knowledge behind it, versus potentially like doing other types of data sets, like even understanding the relevance of why you would care about, just as an example, like excluding a certain type of IP address because it's like a public location, or how you would handle that type of situation is super, super domain knowledge specific to this industry. And so a lot of what we've really had to do is we realized pretty early on that we could not afford to find people that were both really, really high level data engineers or data scientists and that had that understanding of the business knowledge. And so a lot of what has been instead is finding people that are so good at their craft when it comes to the individual skills that they're applying to the project, that instead of them learning technical skills, they're learning the business logic with us. And finding that balance was really the key to unlocking the value.
So, I mean, I'm now probably third company now where I've had a significant number of data scientists or data engineers working for me. One of the things I found very interesting was there's quite a large cadre of guys that are theoretical, if you will, versus the ones that, to your point, can apply the business knowledge, right? How do I solve a business problem with one of these things? And so that was where we've struggled in the past, is to find people that can implement business solutions as data scientists. Sounds like you've got that one cracked, which is quite good. So one question I was going to ask you, because it seems like, and it leads me to another question I have here. So did you guys raise funding to build the company, or have you grown organically? Because it seems like you're very, very focused on your cost base, which is amazing, because most startups are just like, let's just throw tons of money and we'll worry about making it cost effective later, right? Did you how did you sort of get going with the business?
So we raised a pre-seed and a seed round already so far.
Okay.
So all that stuff is public on Crunchbase. But the reason that we're so focused on cost is because essentially our business is kind of, well, first off, it's like, I think we're in a new world where if you're raising venture capital, they care about your margins. They care about, it's not growth at all costs anymore.
That's true.
And we're pretty close to profitable at this point, even without the venture capital that we've raised. But similarly is that our business model is essentially like we're a utility, right? Even though we have all these different, things that we're offering in terms of analytics and analysis, that at the end of the day, people want to be able to know that they made money from the data that we give to them, and they want that to come to them at all times. And so because of that, when you are operating a business like a utility, that a lot of times purchase a decision of the customer, yes, they care about, like having, if we're going to make an analogy, like the fastest internet, right? But they also care about the price as well. And so from our perspective, being able to offer the cheapest price for the product on top of the best performance at the same time really comes from us being able to essentially leverage the technology foundation that we have to be able to drive those margins down. And to drive the margins up while driving the prices down. And so like I actually think that a lot of the VC money we've deployed to development has actually been having a much more complicated infrastructure than I would imagine our competitors do. But that essentially allows us to execute at a level where our pricing is a fraction of what they're charging for the same thing.
So the other question I was going to ask, which was a bit related to this, I found very interesting, was that you guys offer these ad credit lines to your customers, which I thought was such a unique idea. I don't think I've ever seen a tech company offering money to its customers in this way. Maybe can you talk a little bit about that?
Yeah. So essentially, one of the things we realized early on in the business is that we had a ton of customers that had like really, really profitable return on ad spends or return on marketing, but that were not spending more because they were cash strapped for some reason. And specifically, our clientele are these e-commerce stores where the VC market for e-commerce brands has gotten hammered over the past 18 months, 3 years. And so because of that, a lot of them are in these really, really unique financing situations where they, under normal circumstances, would be able to raise tons of money and keep growing at a massive pace, but they don't have traditional assets that they would be able to get a loan off of, right? Like really their only assets that they have are like inventory, for instance, right? But from our perspective, we have this unbelievable technology platform where we can see the trajectory and the effectiveness of their ad spend in comparison to the revenue that they're generating. And we can, because of this graph that we have, like really understand like if they are an underwritable client or not. And so because of that, we realized that if our business model is tied to, we charge based on how much data they're getting from us, which is tied to the traffic going to their website, we realized that, we might as well give them the capability to scale up if they are already doing amazing. And so we've had these unbelievable success stories where there were these companies where they were at like a 3-5x return on ad spend, killing it, but they can't get money for some reason. We give them the expansion to be able to, triple their budget on their meta ads or whatever. And now they're killing it, right? They can cover these fixed expenses that they have, buy more inventory, whatever it is. And then they use our platform more because their traffic's gone up.
Oh, that's fantastic. Very clever.
Jonathan, so we have a small tradition in the podcast that the guest presents a book that they would recommend. And the one you send us in advance of this recording is Monolith to Microservices, Evolutionary Patterns to Transform Your Monolith by Sam Newman. Can you tell us why this one was the one you recommend? And then I guess I will have the questions for you, like, have you already implemented microservices at the revenue role?
Yeah, so the backstory of that is that at my last company at Ticker Talker, it was this trading platform that had been built on these massive, like, monolithic .NET stacks of technology, right? Like they had built this platform over 10 years for this like internal hedge fund application. And then they came to us to bring it to the web and to make it, retail investor friendly. And the problem with that platform was that any little update required this massive change of this insane interconnected architecture that, essentially made it where it would take months to release any type of feature of any type, and anything could break anything, even with, all types of QA and QA automation and things like that in place. And so in between projects, I read that book and it like opened my mind to like, this is the absolute reason why this other project had all these problems and why it was so hard, like, why it was like so like trekking in mud in order to just get individual features out there. And so being able to start Revenue Roll from scratch, I had the opportunity to plan the architecture from scratch, and everything in our entire project now is completely built on microservices. There is not one aspect of the project that is not independently deployable from something else. So every single, like part of the lending system is completely independent, different services, different database, different UI, branches, like from the, the data pipeline, each individual service, like the tracking, the streaming, the traditional relational database, the graph database, the data visualization, every single thing independently deployable, its own APIs, its own databases, its own, like services supporting them. And so because of that, I mean, it's been definitely not easy in terms of like any startup in general, but it has been the problem we haven't had, which moving to this new concept that I learned from that book taught me, is that nothing is blocking anything else now for the most part. That like there is no one developer waiting for another developer to deploy the next thing. And so because of that, it means that we're able to really be as nimble as each individual resource. And also in terms of like you guys were asking before about like measuring like how you get like a good data engineer, data scientist, that becomes a lot easier to measure and understand individual developers' performance because you can see how quickly they're deploying things in production really, really easily because they're not blocked by anybody else. And so, it's like a totally different mindset. And there's definitely some cons in terms of the complexity of the architecture of doing it this way versus, when you have everything all together in one place. And it might be a little bit more expensive, but the trade-off in terms of agility, being able to have like things not be interconnected for, QA problems. I mean, it is absolutely the biggest shift and the smartest thing that we have done as a company up to this point, and it's because of that book that we did it.
I've used a mixture of these architectures, right? My last company, we were very big on microservices. But one of the problems we ran into was we had teams that would often be quite far ahead on developing back-end changes versus the front-end guys then waiting for those new endpoints or those changes to be available. So is that an issue you run into, and how do you deal with that if it is something you've seen?
Well, the big benefit of our service is that it's not super dependent on the UI for providing value to our users. Because at the end of the day, like a lot of what we're providing is dumping and streaming and placing data in batches into external sources, whether that's like ad networks, whether that's people's ESPs, whether that's deploying changes to like their on-site customization software, things like that. And so our UI is really for like monitoring the status of these backend processes that are happening. And so because of that, like we essentially, even if the backend team gets ahead of the front end team, and they definitely are in terms of the current status of the project right now, that it doesn't necessarily mean that the customers do not still continue to gain the value of the rest of the platform, because anything additionally added to the match quality, for instance, the data we send in, they see that effect in their bottom line, like they just make more money, right? Even if we can't necessarily visualize for them exactly what that change was until later.
Yeah. I mean, I used the front end as an example. That probably wasn't the best one considering your business, but I suppose I've seen, again, situations where we had, different services consuming different data, processing different data, AI backend services, where there might be a change being made in one that another service is waiting to consume, right, to do something else with. So, like I say, in my example, it was front end was a problem for us. But I guess with your setup, it's a bit different, isn't it, really?
I think there's also an aspect of it where it's like, I think maybe a better analogy for us is because it's like a data pipeline and it's starting with tracking and streaming and then ending with like visualization at the end, right? And so there are times where the tracking and streaming layer might block the, the ETL, like the transformation, the graph modeling, like the AI aspect of the platform. But I would say, generally speaking, for the most part, that we actually built out the tracking and streaming aspect of the platform first and with a much more higher level of complexity. And then we build everything else afterwards on top of it. And so because of that, it's very rare that something is needed to be added to the tracking or streaming layer that will take longer than the requisite work that will need to be done afterwards in the ETL layer of what's happening. And so I think it's just maybe because of the varying levels of maturity of the different aspects of the microservices that we don't run into that problem quite as much. But I mean, that's a great question. I guess maybe I'd have to reflect on it a little bit more to know if it's ever happened.
Well, I suppose we would reinvite you in a year or two when you've grown a lot and have all those problems to tackle.
Can't wait. Hopefully less problems, for sure.
there's always problems. They just get different and bigger, right?
For sure.
Otherwise,
And
we wouldn't have a
also,
job.
it's a lot easier fixing problems when you have like tons of active customers and like what you're building for
Yeah, yeah.
than when you're in the Wild West before you found product market fit. That is for sure.
Oh, for sure, for sure. Well, Jonathan, thank you so much for joining us today.
Yeah, thank you
And
guys for having me. It's been awesome. It's been amazing.
amazing. And for everybody listening, we'll be back in 2 weeks. Bye bye.